Our third speaker is one of the young fellas who are helping craft and revolutionize the taxi space. Give it up for Michael Cheah.
Testing.
There's a bit of a delay, so try to plan a little bit and press first. So, yeah, next. Okay, all right, take it away.
Hi everyone, thanks for coming. I'm Michael. I'm the lead mobile engineer of My Taxi. You might be wondering why mobile engineers doing here talking about internet architecture, right? But in fact, I joined My Taxi in 2012 as their first system admin. So I have the chance to help them to build and plan their first few iteration of the architecture. So everybody knows what My Taxi is, right? Who use My Taxi? Well, there's a lot of people. So for those of you who don't know, My Taxi is a taxi booking service that allows you to book taxi around KL, Singapore, Thailand, Vietnam, and Philippines from your smartphone. We've been around for 2 years now. We actually, in fact, just passed our anniversary last month. So, yeah, thanks for your support. So before we start, let me just share with you the kind of scaling that we have experienced in the past 2 years, right? So flashback to 2012, we were doing about 200 booking a day, if we are lucky. And there were around 50 drivers online at any one time. And back then we were just in Malaysia. So flash forward to today, we might be able to do that same amount of booking in a minute. So the number of online drivers at any one time, of course, it has grown a lot because now we are in different countries. So we have grown at a very rapid pace. And tonight I want to share with you one of the most challenging and most important part of our business actually, which is to be able to know where our online drivers are at any one point. So this is very important for our business because for those of you who don't know, we assign the closest driver to a passenger when they make a booking. So passenger make a booking, driver say yeah, maybe yes or no, and then we look at the drivers who say yes, and then we give them the nearest one. So having a very accurate location data of the driver is very important because it directly impacts the efficiency of this system. Also, the happiness of the driver and the passenger is ultimately decided by, like for example, how long the passenger had to wait before the taxi comes to them, and for drivers, like how many jobs they can win if they are close to a very strategic location, for example. So it's very important for our business. But when we actually look at what we want from this location data that we gather from the driver, we actually are just looking at two kinds of questions, right? We want to be able to ask, for example, how many drivers and who are the drivers that is at this particular location at this point of time, like right now, right? So this kind of question we can get if we keep a copy of the real-time location data. And the second kind of question we want to ask, for example, did this particular driver pick out this particular passenger from point A to point B last week? So this kind of question you can only ask if you keep a historical copy of all your location data, right? So with that in mind, I would like to go through our one of our very early architecture of the system. So this is around September 2012, and as you can see here, there is a single Node.js backend app that sits in the middle of that picture. And when I say a single Node.js app, it really is just one single server in the cloud. I'm not kidding. Yeah, that was how small we were. So this Node.js backend application will talk to the driver mobile app as well as the passenger mobile app. So it sort of coordinate between them two. And in this system, all the transactions actually ends out in the one couch DB server sitting there. And therefore, it includes all the location updates that you get from driver. You will have to be saved inside CouchDB database. And when you want to query like the real-time data, you have to go through the database as well. So it really is the center of the universe there. As for the historical data that I talked about, this is how we store it. So basically, as you can see, we just save the ID of the drivers, the timestamp, the latitude and longitude, the accuracy, and the source. So these are really just text file. We just append to this text file as the location updates comes in. And this text file resides on the Node.js backend app that you saw just now. I guess the advantage of this approach is that it can easily be managed, like log rotated, and you can compress it and store it. And that will ensure that it doesn't grow too large. So everything's good, right? Or so we thought. The system runs for a while. It works fine. But as you all know, we expanded rapidly in Malaysia. And as supplies and demands grow, more and more online drivers, the number of online drivers become higher and higher. So eventually, it become like this. So we sat down and we did some calculations. So assuming that a drivers send us location update every 15 seconds, right? So assuming that on a day when you have around 500, on average around 500 online drivers at any one point, that roughly translates to around 33 updates per second. And this goes into the CouchDB database. And to put that into perspective, that is close to 3 million updates per day just for location updates. Nothing else. And we look at that number and we're like, wow, this is crazy. It's not scalable. So what we did was, we brought in Redis, right? So as the speaker just now mentioned, Redis is great. We love Redis. It's basically an in-memory data store. It's very fast for what it does. So we think that it's suitable for the kind of usage, like location updates that goes in very frequent, and then we read it very frequent as well. But it wasn't actually that bad if Redis goes down, because the data is still persisted to this every, short intervals you can configure, so that if it goes down and comes back, you still have the location data, right? So it's very fast. With just this simple change, our system works fine again, right? So in fact, Redis is so performant that as we evolve our architecture, it remains as the primary real-time location store. So this is around mid-2013 when we split the backend Node.js app into just one part where it talks to a driver and another part which is done on Ruby on Rails that just talks to the passenger. And both of them share Redis as the real-time location store. In fact, we like Redis so much that we actually added other functionalities to it. So it kind of does a lot of stuff, right? But it still holds up, right? It works. And actually, by mid-2013, we were doing a lot more booking than we were back then. And yeah, so Redis is really great. But is it enough, right? Is this enough? So, stop updating. It's lagging again. Yeah. So, when we come back and review that architecture they have right there, we realize that there's mainly three deficiencies with that architecture, namely redundancy. And what I mean by that is that Redis is so important to us that if it goes down for a long period of time, for example, everything else would just not work. Like you won't be able to find drivers near to this passenger and other stuff, right? So we need some kind of fallback. If Redis goes down, we still need the system to work. And the second thing is that you remember the text file that we used to keep in the Node.js app? Yeah. That's not so great when you want to do geospatial analysis. And what I mean by that is like, for example, you want to ask, last Friday, which part of KL has the most driver? Right? This kind of question, you can't just ask the text file, hey, where is it? It will take a lot of effort, and it's not worth it. And the third thing is, as we scale our backend architecture, we have more than just one instance on Node.js, and that text file becomes sort of like everywhere. So it's very hard to consolidate all of them from all these different instances. Some of them can be very large, like 4 GB in size, just for text file. So it becomes a pain. Ideally you want somewhere that can store all this data together and everybody can just read from there and get what you want, right? So we went back to the drawing board and we designed a new system that takes into account all this. And this is what we came out with. So this is around mid-2014, and it still roughly look like this right now. So as you can see there, when a driver sends us location updates, we write it concurrently into both Redis as well as Postgres. So we set up the Postgres master database as a write-only database, right? So all the writes goes there. And the master Postgres DB is replicated across the network to a different data center using something called the streaming replication of Postgres. And the slave in a different data center is set out as a hot standby, right? So all the consumer of this real-time location data will read from the slave. So this read only, right? Can't write to it. So this solves all three of our concerns just now. So for redundancy, let's say the Postgres master goes down, right? The slave is set out as a hot standby so that it automatically promote itself as a new master if it detects that that master is not there anymore, right? So in that way, you can still write to Postgres and your consumer can still read from it, just from a single instance, until we bring back the old master, right? But what if the slave goes down? If the slave goes down, the consumer has its own built-in mechanism to fall back automatically to Redis. That's why we write the location update to both Redis and Postgres master, right? And if Redis go down, we don't really care anymore at this point, but yeah. It's good to be there. As for the second concern, the geospatial analysis, right? So Postgres allows us to install this extension called PostGIS. So basically you can do the analysis in the database itself, right? So you can ask, last Friday, how many drivers is here at this location, and that kind of thing. And for the last concern, text file were everywhere, right? So we get rid of the text file and it's not a problem anymore because all our historical data is now stored in Postgres, and you can just go there to get whatever you want, right? So these are some further readings that don't have time to go in depth, so you guys can check this out. I want to highlight the second one, which is WAR-E. This one is a simple continuous archiving for Postgres. What it means by that is that we don't just store the location data in Postgres on that master instance itself. It's actually continuously being backed out and uploaded incrementally to somewhere else, for example, Amazon S3. Yeah, so do check that out. Okay, so yeah, we are constantly looking for talents. So if any of these things interest you, do by all means come and talk to us, get in touch. I think that's all from me. Thank you very much.